Okay, here we are, Chapter 7, Day 1, Part 3. So, you know what? You're wrong. That's all there is to it. You're just wrong. Because it makes absolutely no sense to me that salary is going to predict wins. What actually makes sense to me is that the number of wins you have is going to predict salary. That's what's going to happen. So this is wrong. I'm going to switch my variables around. I want a new graph. Here we go. New graph. And I'm going to say that wins on the x-axis is going to predict salary on the y-axis. What's this graph going to look like? I happen to know. Well, let's take a look at it. Here's salary, or sorry, there's wins, and here's salary, and there's the graph. Is it going to be the same? The answer is no. It's not. It's not the same. But it is the same data, and it's in the same place. And what it is if you take your hand and you take the graph and you flip it and then you rotate it, and out, that kind of hurts a little bit there. That's this graph right here, okay? Which means it's reflected along the equation y equals x. That's what it is. It's reflected along the equation y equals x. But it's relatively the same. Here's the Yankees, all right? Down here's the Pirates, and you know what? Pirates still suck. That's just the way it is. The Pirates still suck. But they're down here. There's the Tampa Bay Devil Rays, and there's the Pirates. But there's your graph right there. It's looking the same, but it's flipped and rotated. All right. So the question is, what's the correlation coefficient going to be when I switch the axes and say that salary doesn't predict wins, but wins predict salary? What's the correlation coefficient going to be? Well, let's get rid of that yen thing there. Let's bring down a new summary statistics, and we're going to say that wins on the x-axis predicts salary on the y-axis, and your thoughts are? It's 0.49. It's exactly the same. Why is it exactly the same? Why does that make absolute perfect sense? And this is why it makes absolute perfect sense. Because what we're talking about is we're talking about the relationship between the salary and the wins. Not the relationship between this point and this point. We're talking about the relationship between the salary of the New York Yankees and the wins of the New York Yankees. The New York Yankees have $189 million and they have 94 wins. Tampa Bay Devil Rays have $24 million and they have 66 wins. I reversed the scales here. I reversed the axes. You know what? The Yankees are still making $189 million, and they still have 94 wins. That relationship is not changing. Tampa Bay Devil Rays still have $24 million. They still have 66 wins. So we're looking at the relationship between the amount of money and the number of wins they have. And that is not changing. So very important, when you switch the axes, the correlation coefficient is not going to change. It's going to remain the same. Okay, now, I want to talk about one more thing here. And that's what I want to do is I want to take these values and I want to convert them into Z. I'm going to get rid of this graph because I don't need that right now. I'm going to convert them into Z. What do I mean by Z? I mean standard deviations. So here we go. Hang on a second, I need to think. Okay, I really hate when that happens. So we got a shorter video there. You know what? It doesn't matter that much of a deal anyhow. Alright, so here I am. I'm going to take these values and I'm going to translate them into Z, which means standard deviations from the mean. We're going to do this on the calculator next time in the bottom part of Chapter 7, but we're going to do it here too because I just want to see this. So I'm going to create a graph, okay? So here's the graph right here. And what we're going to do is we're going to use the z-score in salaries versus the versus the z-score in wins. And notice that this graph and this graph are the exact same thing. Okay? They are the exact same graph again. And that's fine. But let's talk about what we have here. We've got z-scores, and how do I determine if a z-score or if a piece of data is an outlier? Well, if it's beyond 3 standard deviations from the mean, and here we are at the z-score for the salary for the Yankees, it's 3.15. Outlier, Outlier. Let's take a look at the Pirates. I wonder if the Pirates are outliers and how low they are, because no, they're not. Man, they should be. Okay, but here's the same graph, and here's the graph right here. And notice right here that this is the origin in this graph, because this is z-scored. And this is 0 on the x-axis, and this is 0 on the y-axis. And 0 on the x-axis is going to be the mean. And 0 on the y-axis is going to be the mean. Now, what's the correlation coefficient going to be here? That's a really good question. What's the correlation coefficient going to be when I change it into z? Let's find out. I hope that you have an idea at this point. Salary versus wins, and it is 0.49. Because what have I done? I've changed the scale, much like changing salary to wins. All I've done is I've changed the scale. It's 0.49. It's going to consistently be 0.49. Unless I change the data itself, it is going to be 0.49. Okay, that's the beginning of Chapter 7. There we go.